Hey, welcome to a little physics here. This time we're going to be looking at kinetic energy. Kinetic energy, amazing thing. It's just sort of one flavor of energy. Energy can be kinetic, which means it's in motion, or it can be potential, which means it's there but not quite being used yet. So energy is described as an ability. So it's basically the power behind something to do work. And we talked about last time how work, or in previous videos, how work is a force that causes the displacement in the direction of that force. And that also is a change in kinetic energy. So the idea with kinetic energy is that you have some kind of a system, right? And that system is either giving off energy, right? Transferring energy to the outside world, or the outside world is bringing energy in. So either way, there has to be a change in energy of the system and things happen. Okay, imagine also taking a ball, right, and throwing it straight up. Well, as you throw it straight up, initially it's going to have a ton of kinetic energy, right? It's going to be all kinetic energy. When it gets to the very top of its arc, it's going to be all potential energy. And then energy is going to come back down, and halfway in between, it's going to be what? A little bit of potential and a little bit of kinetic right here, or half and half actually right here in the middle. And then when it gets back down here again, that potential energy will transfer all the way to kinetic energy again when it hits the ground. Right? Then it's going to bounce back up, and then some of the energy is going to transfer into the ground as heat. So energy is constantly moving from this and that to the other, and it is the thing that sort of creates the ability or the power to do anything in our world around us. So analyzing or understanding energy is very, very important in physics. So let's look at a couple of sort of examples or problems. Everybody should be familiar with the idea of baseball. Here's a baseball bat. And so let's say you take a baseball bat, and here's our ball, and let's say that it's on a tee, right? And let's see, so there we go. So you're going to whack this baseball off of this tee. So let's say that you're able to hit it with a force of 150 newtons. Let's say that that baseball weighs 0.060 kilograms. Let's see, what else do we want to know about that baseball? Let's say that the time that the bat is in contact with the ball is 0.030 seconds. Okay, so this is what we know. So here's a couple of questions. What is the kinetic energy transfer from the bat to the ball? So how much kinetic energy is this ball going to have, right? And then here's another one. So here's what I want to know. What's the kinetic energy? So what do we have to do to go about finding that? Well, we know that kinetic energy, right, equals work. We know that kinetic energy equals 1/2 the mass times the velocity squared. So what things do we have in here? Well, we have mass. We don't have velocity. We don't have kinetic energy. We have a force, right? But we don't have a distance, because we know that work could also be work equals force times distance. So what do we need here? Well, we either need to be able to solve for a velocity here or solve for a distance. Well, what do we have? Well, we have time, right? We have time, we have force, we have mass. So we could actually use that to solve for a velocity, because we know that force equals mass times acceleration, right? And we know that acceleration equals a change in velocity over a change in time. Okay, so there's our velocity. That's what we want to solve for. And to put that into here. And here's our time, and we already have our time right here. We have our force, and we have our mass. So this is going to work right here. So let's go ahead and rearrange this a little bit. Let's say force times change in time, which is actually the impulse, is going to equal my mass times my change in velocity. All right, so initially the ball is 0. So we're just looking for a final velocity here anyways. We only have one time, so let's go ahead and start plugging this stuff in. We have 150 newtons, and our time is 0.030 seconds. and that's going to equal our mass is 0.060 kilograms times our velocity final, because we don't have a velocity initial, and this would have been final velocity minus initial velocity, and since that's 0, it doesn't matter. Boom, that goes in right there. All right, multiply these, divide by this, we find our final velocity is going to be 75 meters per second. Sweet, I can put this in here now. So my kinetic energy is going to equal my mass, which is 0.060 kilograms, right, times my 75 meters per second squared, divided by 2. And so I'm going to find that my kinetic energy equals, let's see, I wrote it down earlier here, equals 1.69 times 10 to the second joules. All right, so there's kinetic energy, and that's the kinetic energy that the ball has. Now you could also take this velocity, and using some of our projectile equations, you might be able to figure out, right? You might be able to figure out how far it goes distance, especially if you knew the angle of the trajectory. You might be able to figure out how high the ball goes or how long it was in the air. So using a whole lot of the other physics so far, we can solve a ton of things now, given just a little bit of information. So we just started with this, and so far we know the energy that went into the ball, we know the final velocity of the ball coming off the tee here. Pretty cool stuff. All right, so in the next video I'm going to solve a little bit more complex problem like this, and then we'll move on to even some more complex ones. So stay tuned.